Welcome to Math with Mrs. Seeley. Let's get started with this 2024 free response question number 4. In this particular question, we're given the graph of a differentiable function f shown from -6 all the way to 7. We have a horizontal tangent when x is equal to -2. It's a line from here to here. R is this blue region that's bounded by f, the vertical line, x equals -6, and the x and y axis. And we're also told that region R has an area of 12. A part says the function g is defined by this right here. We want to find the values of g of -6, g of 4, and g of +6. Let's start with finding g of -6. If I want to find g of -6, that's like putting in an x is -6 right here. So therefore, we will have 0 to -6 of f of t dt. So they're asking us to find the integral from 0 to -6. Well, first of all, our limits of integration are backwards. We need to rearrange those so that the 0 is here and the -6 is here because we want our larger limit at the top and our smaller limit at the bottom. And in doing so, we have to put that negative. Here's the other thing that you want to recall. The integral is the area under a curve. So I want the area from -6 to 0. So basically, that blue area or region R. We are told that region R has area 12. So that means it's negative because of the negative out front, and the area under that curve is 12. If you were able to get that value, give yourself the first of the 9 points this question is worth. All right, the next part says to find g of 4. So now I'm going to say g of 4, which means I'm going to put a 4 in for x right here. And once again, we're talking about the area under the curve. So the area under the curve from 0 to 4. If I look at the area under the curve from 0 to 4, we have a triangle right there. So that would be a triangle, and you know that the area of a triangle is 1/2 base times height. So 1/2, the base of that triangle is 4, and the height of that triangle is 2. So do your math, and you get 4 for that area. If you got that value, give yourself another point. All right, the last one says g of 6. So if I want the area under the curve with x is equal to 6, I will have, and I'm putting it in right there, that's where I'm putting that x in. So I will go from 0 to 6 of f of t dt. So now I'm looking at the area under the curve from 0 to 6, which is all of this, from 0 to 6. So I've got this and this. So I've got this triangle above the axis, and I've got that triangle below the axis. So if I do the first one, I've got this triangle right here, the triangle above, and I've got the triangle below. The triangle above, we just did that one, is 1/2 base times height. Because this triangle is below, though, it's going to be negative. And so it's going to be 1/2. His base is 2, and his height is 1. So I will have 1/2. The base was 2, and the height was 1. So that right there is 4. This right here is 1, and you get a value of 3. If you get that correct, give yourself the last point from A. All right, let's take a look at B part. B part, and I went ahead and put that graph so it'd be right there, we could see it again. B part says, for this function g defined in A, and this is what g is. I went ahead and rewrote it for us so that we would have it close by. It says find all the values from 0 to 6, so over here from 0 to 6, where the graph of g has a critical point. All right, so you have a critical point. A critical point is when the derivative is equal to 0. So that means when g prime of x is equal to 0. That's where we'll have a critical point. So I need the derivative of g. So if this is g right here, I need the derivative of it. So let's do that. Let's take the derivative of g. But if I take the derivative of this side, I would need to take the derivative of that side. So therefore, the derivative of g, which means, okay, the derivative of g, g prime of x, but that means I would take the derivative of this. And if you take the derivative of an integral, remember they cancel out, and you just get f of x. So you just get the function itself. So that means that g prime of x is 0. So that means if g prime of x is 0, that means it's when f is equal to 0. So I go back and I look up here, and f is equal to 0 at 4. F of 4 is where that equals 0. So that tells me that the graph of g has a critical point at x equals 4 since f of 4 is equal to 0, or the graph of f is equal to 0 there. All right, for points on this one, if you make the establishment, the connection that g prime of x is f of x, in other words, the derivative of g is the graph of f. If you make that connection, give yourself your point. Then if you're able to say that there's a critical number at 4 because f of x equals 0 at 4, give yourself the other point. Okay, let's take a look at C part. Now we're given a function h. H is defined by this right here. And so we're asked to find h of 6, h prime of 6, and h double prime of 6, and show the work that leads to our answers. All right, first of all, we're going to find h of 6. If I want h of 6, again, that means we're putting a 6 in for x. So here's what we're fixing to do. We're going to put in a 6 right there. So that would equal the integral from -6 to 6 of f prime of t dt. Okay, so again, we are in a situation where we're asked to find the integral of a derivative. We know that they cancel out, and I'm just going to get back the original function f of t. So I integrated that, but remember when you do an integral and you have limits of integration, you actually evaluate it. Use that fundamental theorem of calculus. So that means I'm going to put the 6 in first and minus put in f of -6. Okay, well, let's go back up to the graph and let's see what f of 6 is. In other words, what's the value at 6? I'm going to come up here, and at 6, I can see the value is -1. So that's -1 right there, -1. Minus, now let's go find the value at -6. So if I come up here, at -6, we're told that it's equal to 0.5. So we're going to have 0.5. So minus 0.5. And if I do that math, I get negative 1 minus 0.5, which is negative 1.5. If you know to use the fundamental theorem of calculus, which just simply means you take the derivative of an integral, they cancel out, you get your function, but what it means is that you're going to evaluate it then, f of 6 minus f of negative 6, where you plug those endpoints in. Give yourself a point, then give yourself another point if you find the value of negative 1.5. Okay, the next part says h prime of 6. So we need the derivative of h. So if I want to find the derivative of h, I need to know what is h prime of x. What is that equal to? So if I take the derivative of that, I'll be taking, remember, h of x is defined to be this right here, and f prime of t dt. Again, if you take the derivative of this side, you're going to take the derivative of this side. Those are going to cancel out. So that means h prime of x is equal to f of x. So then if you want h prime of 6, you really want f prime of 6. Well, derivative is like slope. In fact, it's slope of a tangent line. That's what the derivative is. So go back up to your picture, the function f at 6, and let's see what the slope is. So if I come back up here, here is 6, and I'm going to find the slope. All right, let's think of slope as rise over run, literally like this line. What is the slope of this line right here? Well, I'm going to go down 2 and over 4, or down 1 over 2, down 1 and over 2. So the slope is negative 1/2. So then the slope of that line is negative 1/2. If you find that value, give yourself a point. Then the very last one says to find h double prime of 6. Well, let's just go right here. If h, first derivative of h, is equal to the first derivative of f, wouldn't it imply that the second derivative of h is the second derivative of f? So that means we need to take the second derivative, which means we just take the derivative of this, okay? We just said right here, that the first derivative is negative 1/2. So if I want the second derivative at 6, that means you're taking the derivative of negative 1/2. Well, the derivative of a constant, because the first derivative is that constant negative 1/2, then the derivative of that is equal to 0. So f double prime of 6 is equal to 0. If you got that, give yourself your last point. I hope you found this helpful in preparing for your AP exam. If you did, please like, comment, and subscribe to the channel. Be sure to check out other essay question free response explanations and any other video tutorials you might need. See you next time.